Hello everyone, thank you for coming. My name is Morgan Tocker. I work on the MySQL product management team. I just joined this team a couple of months ago. I product manage the MySQL server. My bio outlining probably says that I worked on the community team. I've worked with MySQL for just over 10 years now. I originally joined the MySQL team in 2006. What I'm talking about today is one very specific feature of MySQL 5.7, which is your new ability to be able to store unstructured data along with your structured data. I will have a disclaimer and say that if you don't know what JSON is, it will make this talk a little bit hard. But I will try for the 15-second version and say that it's a way of replacing XML in how you store data, and it's commonly used in APIs. So our agenda today is, as I said, I'm really speaking about this new JSON feature. Before I get to that, I want to talk a little bit about us, tell you about the MySQL team, how we release software, why this release is very important. With database software, with infrastructure software, we can't release new versions that frequently. So 5.7 is just under 3 years in development, and we're very happy with the functionality that we've been able to deliver for you. My main part of the talk will be describing that new JSON experience that's comprised with a few different features that are working together. And then the end of my talk will be to describe, now that you have this new functionality, should you be using it, and should you be replacing how you've traditionally been storing data. So I want to say, please interrupt me and ask questions. I love questions. I'm giving this talk on the back of a 20-day tour through Europe, launching MySQL 5.7. And it's exciting for me, if there's always challenges and there's always interactions. So let's try and achieve that. So to introduce us and to talk about the MySQL team, MySQL 5.7 was developed by the largest engineering team to ever work on MySQL. We joined the Oracle team in January 2010. In that time, we've doubled the size of the engineering team. We've 3x'd the size of the QA team in particular. We know that for a database server, you care about quality, and so we've made sure that we've made big strides in improving this wherever we can. And another small facet of that is we've increased the size of the support team, and this turns out to be important whether or not you're a paying customer, as we loop them in to really make sure that we backport the right bug fixes and we don't introduce incompatibilities as we're fixing things in GA releases. There's another aspect to quality, which means no surprises, even if it does mean a fix, so we're very careful with that. It takes 2 to 3 years to develop a new GA release, MySQL 5.7. It went GA in October 2015. You may have heard us talking about MySQL 5.7 for some time. This is because we have a set of preview releases that you can also download to try out, to get early access to MySQL. So I want to describe those other preview releases because inevitably we'll be coming out with preview releases of MySQL 5.8 as well. We release 2 types of preview releases, one called DMRs, or developer milestone releases, and the other called labs releases. To be a developer milestone release, when we develop a set of new features, we ensure that it has a high-level review to make sure that it works with all existing features. We have a couple of low-level reviews in terms of code quality and code architecture, and we aim for 80% plus code coverage before we present it to you in a milestone. So this is your opportunity to be able to give us feedback with our new features. We say that this is not an alpha, this is not a beta. We know that with infrastructure software, people are scared of that. This is a developer milestone release. That's approximately a release candidate quality. This is a good opportunity for you to be able to give us feedback, as once things go to GA, sometimes to not break compatibility, it's very hard to fix or change things. So some of our top users are using DMRs as early adopters and giving us great feedback. The other type of release that we put out is a labs release. Labs is our way of saying it's not ready. It's really not. It hasn't passed that feature quality, code coverage, high-level architecture, but we want your feedback because this is a directional, this is where the product is going. And there's 2 out there on our labs.mysql.com website at the moment that are really interesting. One is we have group replication, which is like a master replication clustering system where you can read from any server and you can write from any server. And the other labs release that we have out at the moment that's really interesting is we have something called our Data Dictionary Labs release. We're trying to replace some of the core plumbing of MySQL. If you're a long-time user, you're familiar with us using these FRM files for storing data dictionary. We're transitioning to be able to store our data dictionary in InnoDB internally. It's one of the largest projects that we've ever attempted. And this will ship sometime in the future, not in MySQL 5.7. So with that, I said, yes, the final product, the one that you can deploy your apps in, GA, October 2015, what were the main features? This was what went out in the press release saying, hello world, time to start using MySQL 5.7. We differentiated into two categories. We said that it's great on performance and it's great on manageability. And I'm zooming in on that JSON topic in manageability. And I will answer questions on some of these other things as we have time at the end. I think that JSON is a good story, and it is very applicable to all audiences. But if you're an administrator of MySQL, there's some nice things in terms of replication has a lot of improvements. We can apply replication in parallel on slaves far more efficiently. And in a previous position, I was doing a lot of performance consulting with customers. And one thing that I observed the most is those that have performance problems don't have them because the database server is slow, per se. They have performance problems because they don't have the visibility to be able to see what's happening in their database server. And we have two big improvements in terms of our performance schema and our sys schema. On a fresh MySQL 5.7 installation, I can say select star from sys.statement_analysis, and I can find my top 10 slow queries, and I can start optimizing straight away. There's a lot of things you can do once you have that visibility, and I think we're extremely strong in this area. So that was the kind of high-level press release version of what's new. The other alternative view that I want to show you of what's new is I created a website, and I called it thecompletelistofeatures.com, and I had everything that's new. So if you're a long-time user, there's just under 200 items that I discovered from going through changelogs. This website works on mobile. If we get to the end, we cover all the JSON stuff, and you want to ask me some arcane question about number 27 under some category, I'll do my best to be able to answer it. I can describe most of them here. But I just wanted to show that for quantity, just so you don't think that JSON was the only thing that we've added in MySQL 5.7. There's a lot of stuff that we've added, and it's all extremely valuable. The last thing that I want to mention when I said let's talk about us to start with is say that we're committed to build a business around the MySQL product. And we do so by selling a subscription called MySQL Enterprise, where everything that I've described to date is available in Enterprise, and it's in Community. We release additional functionality on top of and around the MySQL server, with the MySQL server itself supporting plugins. So we have things like a firewall to be able to blacklist certain queries to prevent SQL injection. We can authenticate against LDAP servers. We can audit, so you can see what activities happen by what users, a monitoring tool, a backup tool, and of course, we have access to our support team. But with that, we're on to the main event. We're on to talking about JSON. So there are 3 features that work together to be able to create this new MySQL 5.7 JSON experience. They are feature 1, a native JSON data type. Feature 2, a set of functions to be able to manipulate and search and access and retrieve data on the server side with JSON. And feature 3 is we have a set of generated columns, which I'll describe each of these in more detail. The generated columns allow us to apply indexes on our JSON data. So to start with, let's describe the JSON data type, and let's say what's new. Here I have the most trivial of examples. I create a table. I call it employees. I say it's got a column, data, and the type of this is JSON. So previously, well, and currently, you could have had an int, you could have a char or varchar. Now you can have JSON. And you insert into this column valid JSON, as I have here, and you retrieve from this valid JSON. And internally, the way that we store this is not like that. We store this in a more optimal way to be able to retrieve and access this data. And to sort of describe a few of the technical specs behind this data type, we follow the rules of JavaScript and the JSON format, and JSON says that it's only UTF-8 character set, so we don't implement other character sets for this type. Our goal with this data type is to be able to optimize it for read-intensive workloads. And part of that is when you do an insert or you do an update and you insert JSON, that's when we're doing the parsing, that's when we're doing the validation, and we're saving this in a binary format, and then it's going to be very fast to be able to access it. You can think of this type as a little bit similar to like a blob data type, where we store each document internally in a MySQL row, where we have a dictionary, and then we have fixed offsets for fast access to each of the elements in a JSON document. Some other parts of the tech spec for this, we support all of the types that JavaScript does, which is actually fairly limited. We also extend this internally to be able to support all of the MySQL types and have the ability to extend this further in feature. And I will describe sort of towards the end of my deck how this extension works. But it gives really clean, really nice integration between the document world and the MySQL world, and that we extend this. And this is similar to other formats like JSON, if you're familiar with it. It has that extension over JavaScript. So I will summarize the JSON data type by saying, well, Morgan, currently I could store JSON in text or varchar or blob. Why would I use this data type? I want to say that there's two distinctive advantages why you want to use this data type. And I will back up this claim in just a little bit when I show performance numbers. But feature one is that you insert into the JSON data type valid JSON, so you get some validation by using a native JSON data type. And the second reason is that it's very efficient, particularly for retrieval. We do have the ability in future to be able to add additional advantages. I'll talk a little bit about roadmap when I get to the end as well. One thing that might be nice is that if you had a really big JSON document and you just made a small change, if we could just make that small change on the disk when we're doing write activity, or send it over the network as the small change. And we don't currently have that feature, but it may come in future. So these 2 points are both true currently and very true. They're very useful for your applications. So that's feature one. We have a native JSON data type. Feature two is we have a set of functions. So if you had a lot of JSON on your server and you wanted to be able to do some mass migration or some mass update, it could be painful if you had to pull it all into your application, extract it across the network, make a change, and then send it back. It's useful if you have some scripting ability in SQL to be able to modify it or access just part of a document and then send it across the network. So we have about 20 functions. I'll start off with the simplest one, and I'll start off with an example that doesn't have any tables. I'm just on my MySQL command line client creating a variable called document. I'm signing into that some valid JSON. This is a JSON array. And then I'm running a JSON extract function to be able to say, extract out of this variable that I call document the first element, or the second element, depending on how you count, in that we're starting from 0 as our first number. So this is a way of being able to just extract out, as I've highlighted in red, the value 20. So JSON extract is one of those functions. This works on JSON native data types. It works on strings that are signed in variables. It works on if you stored text, or if you stored valid JSON in a text column. This is one of the common functions that you would be using. That syntax where it says $ and then brackets 1, this is what we call a JSON path. If you're familiar with JavaScript, you're probably familiar with jQuery, and you're familiar with something like CSS selectors to be able to extract out part of your DOM. Our syntax is a little bit different to that, but the concept is similar. It's very easy to learn how to do this $ and then bracket 1, or $. And then a JavaScript object. It also is easier because we have a shorthand operator to be able to not say the full JSON extract, but just on a column name, you can say -- greater than, And then in quotations, you can mention adjacentpath. And this is the example that I'll be showing in my slides. This is a little bit of syntactic sugar that's easier to use than using a full JSON extract. So I want to show you some performance data, and I want to show you some examples. And I'm going to use a sample data set that you can download and reproduce. The city of San Francisco has a project called Open Data. Many cities have this. They basically allow you as a citizen to get involved in the operating of your municipality. So from various parts of how each individual department operate, when this is presented to you as a citizen, you can make good decisions and recommendations and data mashups and so forth. What I grabbed from San Francisco Open Data was 200,000 documents, JSON documents, that represented parcels of land. So city buildings, essentially. Not very exciting, maybe, but real-life data is good to show performance numbers rather than something that's purely fabricated. So I imported this into MySQL in a very document-oriented way. The parcels of land are called features. I created a features table. I created a primary key that was just auto-increment. And I created a feature column that is JSON. As I said, you can download this data and you can reproduce the same result. Each one of these documents, they look roughly like this. The detail is not too important, but they have a set of geographic coordinates to describe where this lot is, this feature, and they have a set of properties. Because a building has to be on a street, the street's got a name, the street's got a number, maybe it's got some sort of lot number that's used for property taxes or so forth. But I've imported it just into a table that I called features. And as I said, I've done this in a very document-oriented way where it's basically all just stored in one column. So I want to run some queries on this sample data. The first query that I want to show you is just how natural it is to be able to extract using that JSON extract operator and specifying a JSON path to say inside of that document, in the properties, I want to find something that's on the street, Market Street. If you're familiar with San Francisco, this is one of the main streets that runs through San Francisco. So surely in this data set, there must be at least a couple of entries. There's a lot of entries, so I said limit 1. And we can see that we're returning back just basically the first entry that matches in valid JSON. So the thing about Schemaless is that not all of my documents necessarily have to follow the same structure. So it might be interesting to see in these 200,000 documents that I've imported, do any of them not have a properties.street mentioned? Any of these not on a street that's known? And the way that I would write that query, it's very natural in this sort of document to SQL integration. To say that, I would say select star from features where feature, and then the same path here, properties.street is null. And in my sample data set, at least, that's not the case. Everything is specified that it has a properties.street. But in your data set, this could frequently be useful as a type of query that you would write. I'll also point out that I'm using feature and then the JSON extract operator with a path in my where clause. This is valid, this syntax, as a list of columns that I could have in my select list as well. You can use it however you would like to. Okay. So my claim was that this JSON data type is fast. That's something that I said was a design goal of it. And I also did briefly mention that the JSON extract operator and the JSON functions, they will work on variables, text, and the native JSON data type. So what I'm going to show you now is I've constructed a very naive query where I'm intentionally having to scan through all 200,000 of these documents, which could be potentially slow. There's a lot of work that has to happen to be able to scan through 200,000. So you wouldn't run this query on your production system. It's naive. But I'm saying select distinct to be able to have to look through all of them. Haven't added any indexes yet. And I'm finding the distinct feature type. It's part of the document, and the answer is just that the feature type is a feature. So if I run this when my schema is, as I showed you a couple of slides back, the native JSON data type, to look at 200,000 of these in memory, it takes 1.25 seconds. If I alter the table and I convert the data type from what was JSON to be text, it takes 10 times that amount of time. It takes 12.85 seconds. So we do have quite an efficient access by not having to parse, by not having to validate the document, just storing it in a binary format with just these fixed offsets. You can get a better time experience than this in production even further because we have the ability to index this data, which is my segue to feature 3. Said we have a data type, we have a set of functions, and we have the ability to index. So to be able to index JSON, I first have to introduce this function called this feature called generated columns. It's not specific to JSON, but it's specific to the JSON experience that we created with 5.7. So what a generated column is, I have a table, I call my table T1. I have the schema here and the visual representation just up here, which might be a little bit easy to follow. I have a primary key called ID. I have another column called my integer. And then I have a virtual generated column defined as my integer plus 1. And you can see in my table schema, it's got this expression to say that it's a column. My integer plus 1 is an integer defined as my integer plus 1. Virtual columns, they don't really exist in the real life. They're virtual. They don't take up memory. They don't take up disk space. They're generated on demand. An application client, it can't see the difference. But I want to assure you, these don't really exist. They're virtual columns. And here, I have an expression to be able to say that this virtual column, my integer plus 1, is my integer plus 1. You may be able to see where I'm building up to here. This expression could be one of these JSON paths. And once I have a virtual column, then I can actually add an index. And then I can make the query really efficient. So let's do that. That's my next slide. Let's show how to do a virtual column using JSON data on our sample data set from the city of San Francisco. Part of my schema from that previous query was to extract out this column called type. I say alter table features, add a new column. It's a virtual column, feature type. I have to choose a data type for it now, and I'm choosing varchar 30 as my data type. This is where we're mapping between the document world and the relational world. So we do have to choose a data type for the first time. So it has some schema there. And we're saying extract out using this JSON path, feature type JSON. When we do this, this change is basically instant. It's only metadata that has to change. It's completely virtual. But the next step, it does take some time, the time that it takes to build the index. Once I've added the virtual column, I can add an index. And then my previous query becomes very fast. We can go down from 1.25 seconds to 0.06 seconds in this case, from what was 12 seconds prior. I'm writing the query here to say select distinct feature type by the virtual column. I could also use the original expression, and our optimizer internally can frequently find out that there was a virtual column with an index that supports the same expression that I've mentioned here. So you can actually keep it in the original query form as well. But this is how we index JSON, by extracting part of it to a virtual column and then adding an index on top of it. And I would say that your time difference, when I said the previous slide was, or the previous example was a naive example, because I was just trying to run a query to look at everything. I would say that this is a very real-life example that you'd get this time difference and it would be much better. This is because indexes, they have logarithmic search. They divide and conquer, divide and conquer, divide and conquer, and they really do reduce time on big data sets by a significant amount. So generated columns allows us to add indexes on JSON data. It allows us to add indexes on XML data or any other type of data. We just have to use built-in deterministic functions in MySQL for whatever uses this expression. That's the only restriction. And you may have heard of this feature described in other databases as something like a functional index. This is the equivalent, just with slightly different syntax, the ability to index on an expression. And I'll actually clarify that what I've described so far has been something called virtual generated columns. There is a second variety. The second variety of generated columns is called stored. We can actually, with this optional keyword, make sure that they really exist. This will take memory and this will take disk space and will take time to be able to add a stored generated column. Whether you choose stored or virtual, it's important to point out that in both cases you're able to add indexes on top of that virtual column, on top of that generated column. So therefore, I would say that in most cases you want to use virtual columns, and then on top of the virtual columns you want to add indexes. My next slide points out the restrictions with virtual columns though, and that will apply a little bit more context to why we need both. So if you wanted to be able to add an index on a virtual column and the virtual column and the index type you wanted to add was a primary key, this is like a no-go. You can't do this with virtual generated columns. Or if you wanted a full text search index or a geospatial R-tree index, this is a no-go as well with virtual columns. It's not supported. In that case, you need to use the stored variety of generated columns. So this is a very specific restriction. We would love to be able to lift some of these restrictions in future, perhaps. I'm pretty comfortable, however, that it's quite small in use case and that most indexes will just be regular B trees. Any questions about generated columns? No? Okay.
What about indexing? When you try to index a field of the JSON, what will happen with some entry does not contain the field? How it's being treated?
Yeah, absolutely. Great question. So I'll flip back to an example to show you, because it'll be a little bit easier to see. So being schemaless, feature type may not be in every record. That's fine. It will be a null. There is the requirement, though, in our default SQL mode that it must be null or it must match this data type. So if it returns back, the expression you've got here returns back an array or something that's larger than varchar 30, you would get an error as you try and insert new documents because they wouldn't pass that definition. Yeah, so you could use some sort of extra functions to do truncation in your expression or do casting or something like that. But at the end of the day, it must return null or it must match this data type that you've specified here. This is our mapping between the completely free document world and the MySQL world to be able to add indexes. It has to match that data type. Yeah. Another question?
Can generated columns be based on user-defined functions or only MySQL built-in functions?
Currently, it's MySQL built-in functions. I have heard this request before for UDFs. It's kind of an artificial limitation that we didn't allow UDFs because we were kind of worried that they might not be deterministic. But that feature's been noted, and we might lift that in future.
The stored generated column values, if you're updating rows, do they kind of stay in line with the original kind of whatever you've set on that?
Yeah, that's right. So virtual columns are obviously virtual. And I didn't read off my slide, but as mentioned there, you can't update them, virtual columns, or any generated columns. They're just read-only. But the stored variety, obviously data really exists for that. They are what we call material. And they are updated automatically as you do any operations. They're maintained as consistent. Yep. OK, one more. This is a good opportunity to ask questions, because then I can move on to some other stuff with this. Just.
Only works one way, the update. So
The,
if you update the JSON column, the generated one is updated.
that's right.
But if you update the generated one, it's impossible to update backwards.
This is what happens when you try and update a generated column. You get a nasty little error like this one. Even if it's stored, yeah. Sorry, it's not possible. It's not allowed. Yeah, and this is actually an interesting question because if you use like an older version of MySQL dump that wasn't from MySQL 5.7, it sees generated columns like the normal columns, and then when you try and restore, the restore doesn't work. Yeah. It's a very special sort of new feature, and you can't update them. If we allowed that, it would cause all sorts of pain.
Just a quick question about the JSON document. So I guess you can't do aggregations directly on those types, right? So you have to have the virtual columns mapped from the JSON type to be able to do aggregations?
No, you could. You could. So actually, when I had this slide up, I pointed out that I'm using this path expression in my where clause, but you could use this in your select clause, or you could use it in your group by. It can be used in any part of the query.
Oh, that's cool.
Yeah.
So have you done some like a published benchmark or something? Is that how that compares to the normal columns, like just a varchar or something, when doing aggregations, the performance-wise?
I can't think of anything we've published. Okay. Generally, benchmarks are interesting because they're so easy to kind of cheat and so forth. What I think is also where it might not be a good benchmark is because in real production, you're not doing this sort of stuff, which I said was naive, just to give a rough indication. You're using indexes. And the indexing performance of the generated columns is the same as it is for other columns. Because when we create the index, we're materializing as the data type, which is a relational type. So there's no additional overhead by this.
Nice.
If that kind of works around your question.
Yeah, thank you. That's really, thank you.
Just for a better understanding.
Okay.
JSON data type is stored like something a binary tree or something?
Yeah, it's not quite a binary tree, but it's a dictionary with some fixed offsets into the tree of the items. Yeah, we have a work log, which is our internal task system that describes how it works in more detail. There's a couple of extra nuances because we've got the provision to do some padding and other stuff, but yeah. Okay. Excellent. Thank you for the questions. As I said, I love questions. Let's show some more JSON functions, though. This has some power here for you to be able to use this functionality. So something that I didn't point out on my slide explicitly, but when you extract out from a JSON extract function or the shorthand operator, it actually returns it to you as valid JSON. And it denotes that it's in the JSON data type by having these quotes around it. You can see here, I'll show you my next slide very briefly, it's got these quotes saying that this is a JSON data type. Frequently, you might find that you want to maybe cast this as a string before you return this, so you can use a JSON unquote function, which will convert it to a string and just return you the data in this raw form. You may want to, as part of learning this path syntax, I said it's quite easy, but you may want to use something like a JSON search function to allow you to find out what the exact path is for some particular element of data that you know what's in there. So here I knew that in the column called feature, I said match 1 of the word Market Street, and I knew it was in there, and it basically returned back to me the valid path of where Market Street was. And then I could use that if I wanted to write the reciprocal query, which is, and here for the gentleman that asked the question, here's an example using the JSON path in the select list to be able to return back and also see that that matches to Market Street. So a useful function, JSON search. It expects that you say match 1 or many, and it pretty much works as you would expect a search to. We have a JSON array function. JSON array accepts any number of arguments. It returns back a valid JSON array. And you can construct this array using columns, as I have here. I had a primary key called ID, and other JSON path queries to be able to construct that. And then I could kind of nest functions if I wanted to. In a few slides forward, I've got a JSON replace function, so I could replace something, whatever was there, with an array. Another function sort of related to JSON Array, and something strange happened on my slide, is JSON Object. It accepts an even number of arguments. The odd values are the keys of the object, and the even values are the values. So we can create objects, we can create arrays, and we can replace to be able to just modify part of our document rather than doing an update to replace everything by saying JSON replace of this column at this path. Whatever was there, I want you to replace it with something new, which is a JSON array that I'm constructing. So as I said, you can do quite a lot of work server-side without having to pull this data into your application, make modifications, and send it back. And so then you don't have to worry about data across the network. You don't have to worry about locks being held for a large period of time. It's really quite efficient to be able to do this. So I've showed you just a few of the functions that are available. There are more available. What I have on my slide here is the full set that's shipped with MySQL 5.7, and what I've highlighted in bold are the ones for which I had examples for. There's probably just one more function that I'll point out as useful besides the ones that are in bold, which is this function called JSON valid. So many of you are already storing JSON in your database. You may want to upgrade to be able to use the new native JSON data type. JSON valid, you could say select star from my table where JSON valid column equals 0, and you could find the ones that are invalid, fix them, and then you could alter your table to be able to say that data type is now the native JSON data type. So because these will work on the native type and variables and text and so forth, they're quite flexible in being able to do all that. So recap and say 3 features: a data type, functions, and generated columns. There's maybe feature 3.5, if such a thing did exist, which is where I said that these integrate very nicely with the MySQL type system. So I want to show you just a couple of simple examples to say that if I created a document as JSON, and I'm trying to do it on one slide, so I'm using cast operator to be able to achieve that, and I cast the value 1 as JSON, and I compare it to the MySQL one, it compares. And it says this is the same. And if I compare 2 JSON documents that have a key of num and then a value of 1.1, the 2 JSON documents, they compare, and they say that they're equal as well. And actually, if I do some small transformations on these JSON documents, like if they had the same data but the keys are out of order, they compare, and they say that they're equal. And this works with all of MySQL's type systems like date, time as well, where we can get this comparison and this integration. So you can do a join between what's MySQL data type of something in one table and your JSON data as well, and the integration is really quite seamless. So with that, we move to the last part, and we say now that we have this new feature, should we use it? Is it a good idea? And it's up to you what you proceed and use, but I want to talk about advantages for both cases. To start with, old relational way, using columns. That's so 1990s. What's the advantage to this? With big applications, sometimes you find that you spend a lot of your code handling edge cases of anything. And when you have fewer edge cases, when you can rely on some consistency and fewer variations or permutations of your data, it may be useful. So you may be able to enforce this sort of restriction or control at some other part of your application. Maybe your application can manage this schema very efficiently, but certainly the database offers this as a feature, and it can be useful. It can be useful to be able to restrict all of these options that are possible, and that you have some enforced control. It can be restricting too, but it can be useful. Storing as JSON, it tends to be more flexible, and there are some things that really need flexibility. And the example that I like to highlight is, say, I'm a software as a service provider. I have many customers. One of my customers has asked for some customization. They want some custom fields. And in a relational way, I think this is painful to be able to make those customizations. Sometimes I try and talk my customer out of it to not have to do it. And what has kind of traditionally been the way that you do this in a relational database is you have these auxiliary tables and you store data in EAV, entity attribute value, kind of similar to key value pairs of extra attributes for this customer in a way of being schemaless in a database way. EAV tends to hit a couple of pain points in how databases work internally. Very short rows have more overhead because we have metadata per row that ends up adding up. And it tends not to generate good query execution plans for the optimizer that has to execute queries internally. So when I think of this problem and I think of JSON data type, I can't think of a good reason to use EAV. I would prefer to use the JSON data type basically every time. I've gone over in my head this problem a few times, and I just think that JSON is a better way to be able to store anything that's of variable attributes. The other thing that's kind of nice about doing it in JSON for this same problem continued is that it's generally more performant. It naturally allows an optimization called denormalization, where you're grouping stuff that's frequently accessed together to be stored together. This can be a performance problem too, right? There's cases to normalize and cases to denormalize. But generally, if you're accessing the stuff together, you want it stored together. Because the clustering of stuff together means fewer logical pages that you have to access and results in better memory fit and all sorts of things. So I think that this is a valid optimization that's not true for EAV, for example. We also have the nice thing that as our tables get bigger, we don't have schema changes. If we want to change the schema, we just start sending different data to the server. We've made this problem less of a problem in more recent versions of MySQL, where we can add indexes and make table changes, some table changes, without blocking the tables so they can still write, and the operation happens in the background, but it's still not problem-free. It does a lot of stuff internally, even if it makes it happen online. And I think that it's very good for prototyping to be able to just start sending values to the server. That point I mentioned prior as well. There is such a case that we may be able to find some happy medium between the two. And I sort of did describe the happy medium when I described the SAS application. It was the variable stuff that I wanted to be in the JSON columns. But if we take maybe another example, and we look at my laptop and we try and model my laptop, maybe I'm selling PC components or something like that. There's some commonality, and maybe on a lot of pages I need to know the name of the product or the name of the part, whether it's RAM or it's a CPU. I need to know the price. I might need to know the vendor for some categorization. But then there's some stuff that's very category specific. Like I might have core count for CPUs, and I might have gigabytes for memory or gigabytes for SSDs. And I think that this is another opportunity where you could have those attributes as JSON, if there's some per category differences, rather than having everything schemaed or everything schemaless. There's some natural stuff that's common and could be valuable to have it enforced. So that's more or less it. I just have one slide left besides some links, and that's to say where we're headed. I'm very happy with V1 of our JSON experience. I think it's very compelling. We have some opportunities for some optimization if you have large JSON documents, where we could do a partial write internally that I did mention prior. I would say that this is not a big deal in most cases. It's good to keep your JSON documents small, because even though we'll support JSON documents up to a gigabyte, it's still row-level locking. So if you've got multiple people trying to edit big documents at once, it might not be perfect for performance. I mentioned that we have limitations on virtual columns, where you can't have full text or GIS indexes with virtual generated columns. You need this stored. And the last point I haven't described yet, what we think would be really interesting is if it's truly schemaless, even a document I had phone number, and there could be one phone number or there could be 3 phone numbers, wouldn't it be really nice to be able to index it so that it could index that array of values for phone number, and there could be multiple entries in an index for each individual row. And we call that a multi-value index, the ability to do that. So we don't support that currently, but we think this brings exciting opportunities. So we hope to head in that direction in the future. And as I said, my last slide is just some links. So when you download my slide deck, you can find out more information on how this feature works. And with that, I'll say, any questions? Oh, lots of them. OK. I'll go for this one first. OK, I think.
Hi. Correct me if I'm wrong, but previous versions of MySQL, when you would do some alter table and text fields, it would copy the whole table again. So how that's going to work if I'm migrating from a text field to a JSON table performance-wise? I'm telling this because I had a big table like 700 megabytes and 200 million rows, and every time I needed to do an alter table on that table was painful. Yeah.
So if you add a column or you change data type, those sorts of things have to rebuild the column, have to rebuild the table. But if you add an index or something like that, that doesn't have to rebuild the table. That just has to rebuild the index. So within that subset of those operations, we can add columns without blocking reads or writes. We can't change the data type without blocking writes. We have to block writes to be able to do that. And that's a current limitation. You can get around this in a number of ways. You could add the column to a slave first, and then you could make it a master, because your application is logical. Or you can use triggers to be able to create a shadow table and then promote that shadow table to a master, and that's very common as well. I will note on triggers, we did make one improvement that's very useful in MySQL 5.7, which is you can have multiple triggers per event, per table. And that does make this use case for that a little bit better. But yeah, I did point that out as this is one of the limitations, painful schema changes that you have in the structured world. And I'd love to make improvements there, but that's the current state.
Okay, just another last question on the same subject. So one of the problems I faced, it was high I/O from text fields reading it. I discovered there is a configuration on MySQL where it tries to calculate the row size, and if it's too big, it creates a temporary table behind, so you have a high I/O input. I did a really change from EC2 to RDS instance on Amazon, and our I/O went through the roof, and then we discovered it was because of the text fields, because a text field can have up to 4 megabytes, and it was different from the configuration there. So how read works on JSON fields right there? Like if you have a lot of access to that, it will create temporary table behind and stuff like that.
Yeah, so the behavior is similar-ish, but a little bit different here in MySQL 5.7. So if you use a text or a blob or JSON, it can't use the memory storage engine for temporary materialization for execution. It has to switch to its disk-based method, which in earlier versions was MyISAM. Now it uses InnoDB to be able to do that. I do think that InnoDB is a little bit more efficient at that because we use special InnoDB.
We do use InnoDB. MySQL creates a temporary table. Why? Because the result is going to be big. Because it's a text field and try to return to you the value. That's why I'm saying not using memory as on a storage. It's just it creates a memory table to retrieve me the result. Yeah, but
the memory table is probably MyISAM in prior versions. It's probably not InnoDB because we only added a switch to be able to switch that to InnoDB, I think, in 5.7. So it may be more efficient. There's some other optimizations in that area where sort buffers now pack to variable length in MySQL 5.7. So some of those aggregates can be more efficient. Sometimes there are better indexes for filtering predicates and so forth, or other tweaks that you can make to your query to be able to reduce the size of that temporary table. That's the most generic advice that I have without seeing the query. Yeah. Next question. At the back, because they may not always get opportunities.
You showed us the comparisons against text and JSON there. Have you done any comparisons using NoSQL databases holding JSON data with?
Yeah, I get asked this question a bit. No surprise. We added this functionality. It is competitive, but it is also at the request of our customers. they have the same needs as everyone else. They want to be able to store unstructured data. Benchmarks are terrible in that they're so easy to cheat that it's funny. If someone created an industry benchmark, then we could show our scores to it. I think benchmarking someone else's database and saying why it's shit isn't really good when a lot of your customers are corporate and people expect better ethics from Oracle. So it's just hard territory to be able to do that. I can't stress that enough. It's really easy to cheat in benchmarks. There's a flaw with every one of them, and we want to hold ourselves to a higher standard. So I don't have numbers comparing. Yeah.
Will this JSON thing, will it build in Oracle also?
Yeah. So,
sometimes?
I speak for the MySQL team, not the Oracle team. But what I want to say is that JSON is a draft specification for the SQL standard, and while I think we have a very good implementation of that, this is also present in Postgres, Oracle, DB2, SQL Server, SQLite, and some other databases I'm probably offending. We're all moving towards this direction. So, yeah, I think you can expect... we've all jumped the gun and we've all added it before it's actually a standard. It's still a draft. But I think without speaking for those other databases, you'll frequently see this appear. Yeah. Yeah, well, that's close. Pass it that way.
Okay. What size JSON is too big for this field?
Yeah, so what size JSON is too big? I like to tell people that JSON is the same size as a row or a little bit bigger. Sometimes a little bit bigger because there's a nice use case here. You can read data from APIs and stream it to the database and then process it later. It's too big if it starts having contention because it's still row-level locking, or if you're updating it frequently and just updating a smaller part of the document. This could have some write amplification happening in the background as you update it.
So you wouldn't advise putting in JSON data like the data that's being stored in blobs or text fields?
Yeah, I mean, it's very similar to a blob or a text internally, so it makes no difference there whether you choose JSON, text, or blob. But typically, if you're storing not one customer but many customers in an individual column, that's the wrong design. It should be one row per customer. Yeah. Okay, there was some more questions back that way. I saw the hands up before. No? Okay.
Sorry, it's another benchmark question, but it was on one of your slides. Your sales pitch, hi. Your sales pitch slide said that MySQL 5.7 was 3 times as fast as 5.6.
Right.
Is that a real-world sort of performance? Would I expect to see that? Or
So,
have you cheated on the benchmark?
We're allowed to. Yeah. So we are allowed to compare to ourselves. I think that's fine. It's comparing to others that I said was bad, so you can't catch me out on that one. I can tell you where we get the number from. This is a peak number. On a big server, we can now do 1.6 million queries per second. Previously, our number was a third of that. I don't think everyone is running these big servers, but something to consider is that each GA release is supported for 8 years in total, and not all workloads shard perfectly, related to working set and some other complexities. So I think it's great insurance to be able to know that we can scale on big systems with that future in mind. Yeah.
Thanks.
2 more questions here.
When it comes to JSON object and you've got nested objects or hierarchical data, is there a limitation on the depth of the data you can put in?
No limitation on the depth, just a limitation from the practical amount of row-level locking, and if you update it, that it must rewrite the full thing. Yeah, so I like to say, if you need a rule of thumb, keep the full size a meg or under, even though the maximum size is a gigabyte.
You said relational ways are so 1990s.
I was just joking.
Do you think that, well, but But in seriousness, do you think that schemaless is the way that MySQL will eventually go, or will you always hold out as relational first and JSON's like your added extra?
We are committed to improving this use case even further. Yeah.
Thank you.
I have a question about if you're doing a select on a JSON column on a particular key that's in there using the path, can you do any sort of operator on that? Can you do a like? Can you do, all sorts of string operators on those values?
Right. So there is another function that you can do some sort of like, similar to a JSON search. I forget the exact function arguments to be able to do that. But you can do a wildcard match in those functions.
Thank you.
Yeah.
Just to follow on from a question earlier on where you were talking about the possible standardization of this feature across SQL.
Right.
Is the implementation you've just described and the methods that you've just described is that kind of matching up to some draft standards so that it actually will look quite similar across the piece? Or is this, have you just had to go your own way because there's nothing really ready yet kind of thing?
Both.
Right, okay.
So let me pull up the list of JSON functions, because that's kind of interesting, right? When we put out a labs release, which was our first preview of this JSON functionality, we actually named all the functions, instead of JSON underscore something, JSN underscore something, to be able to not basically take the namespace of what inevitably be the standard that could have different arguments for each of these functions and so forth. And we got overwhelming feedback from people saying, this is just bad for usability. You should call it JSON. And everyone else had called it JSON. And so we're all in the same boat that if the standard chooses a different implementation, reconciliation and maintaining backwards compatibility may be interesting. Yeah. Yeah, maybe we might have to have a mode saying, how we should behave, standards compliant or non-standards compliant. We are committed to following the standards where, we don't break backwards compatibility in doing so it's not change for the sake of change. And I would like to be able to follow that in future, but every database jumped the gun. We all implemented this before it's a standard. I think it'd be great to be a standard. It makes a lot of sense to me, this use case.
Okay, thanks.
Okay, I think we're done.